Alright, Chapter 12, Westinghouse Brakes. We're in the middle of a steam locomotive engine manual. 12.1 combined automatic and non-automatic brake equipment. Number 7, single-headed pump governor, purpose and operation. Operation of a single-stage piston Westinghouse pump. Action on steam through and on a double stroke. Action on an air end of the one double stroke. 3.5-inch bulb type, triple valve. Description: charging with auxiliary reserve. Application of the brakes. Release of the brakes. Number 4 driver valve. 12.6 operation of the number 4 driver brake valve in the five positions of the handle. 12.7 the CM 6-feed valve. The purpose of the CM 6-feed valve. The method of testing the CM 6-feed valve. Further tests: automatic slack adjuster purpose operation in 12.9 passenger intercommunication gears on carriages. Westinghouse brake system: automatic and non-automatic brakes equipment. The combined automatic and non-automatic engine tender and equipment consists of the standard automatic arrangement with an addition to the non-automatic brake valve. The valve, a few simple parts of permitting the use of straight-up air operation when the engine is tendering the brakes without interfering with the automatic action when the automatic brake valve is used, both being operative at all times, with many important advantages of the independent engine and the tender brake of thus the intent while preserving the function of the automatic brake on these trains and brakes. Refer to Figure 11, Annex A. This figure shows the layout of the diagram of the combined automatic and non-automatic brakes as fitted to the engines and the tenders. The Figure 12, and refer to Figure 12 in the Annex A. The figure above shows the plan of the section view of the non-automatic brake valve. The plan view shows the relatively position of the operating handle. Position number 1, ordinary running position, also release position of the operating handle. In position number 1, the air of the main reserve enters the G as flow through the chamber on the top of the rotary valve. The non-automatic brake pipe, the opening the exhaust through the points of the D and C, the valve C, the cavity B, and the rotary valve. Position 2, the lap position, holding the position applied after the non-automatic application. If position 2, all parts of length and communication between the passages F and E in the cutoff. Position 3, application position, emitting air into the main reserve to straight air pipe. In position 3, the air of the main reserve is emitted to piston passage F through port A, and if the rotary valve and port D is in the seat, the exhaust passage of E is blanked in the position. Refer to section 12.5 for the details of the non-automatic brake valve. 12.2, number 7 on the single-headed pump governor. The purpose of the pump governor is appliance for the automatically controlling the pressure in the main reserve. It is fixed for the one on the steam pipe leading from the boiler to the pump, consisting of 3 vertical chambers mounted above the horizontal steam passage. The upper chamber contains the diaphragm stem on a regulating spring and wash regulating pump plug screw into the top of the chamber. Is located with the position and is protected by a cap nut. The small relief of the port of the side of the chamber allows the escape of any of the main leak past the diaphragm plates through the main reserve. Attached to the middle chamber is the main reserve connection with the air strainer in the passage in the chamber that are the diaphragm plates of the supportive ring and the pin valve. The pin valve spring guide with the pin valve port with leads to the passage to the vent of the port with the top of the governing piston. The lower chamber contains the governing piston, and in spring, the steam valve of the piston passes through the bottom of the lower chamber, works from the guide, but provided with in the chamber, it is secured with the governor piston by two nuts. The drain port of the bottom of the lower chamber to allow the escape of the steam and air, and pipe of the connection being fitted into the outside. The steam passage contains the steam valve and its seats, with the valve resting on the upper seats. The steam is prevented with the entering under the governor piston. When the resting of the lower seats, the steam supply is to pump off, and pump is cut off. The valve is normally in the normal position with the lower seat open. Refer to Figure 13, Annex A. 12.2.2 operation. When the pump is working with it delivered into the main reserve from the pressure under the diaphragm plates in the middle of the chamber, when the pressure of air below the diaphragm is greater with the resistance of the regulator spring, which is 90 pounds, if the spring is compressed with the diaphragm center is forced up and resulting with the pin valve being lifted with the pin valve port being open, the main reserve air flows to the top of the governor piston, allows the vent out of the vent port. The governor piston is forced down with the compressing piston spring until it shuts down the steam valve, thus stopping the supply of the steam to the pump. The main reserve air escapes slowly through the vent port, keeping the pump working and slowly to prevent the condensation. The pressure below the diaphragm plates becomes less than resistant, but the regulating spring of the diaphragm center is forced down, closing the pin valve at the port of the cutting of the main reserve air for the top of the governing piston. The governor and piston spring in the seam under the seam valve and lifts the valve. The air top of the governor piston escapes through the air vent of the port atmosphere and the steam again is supplied by this to the pump. 12.2.3 operation single stage Westinghouse pump. 12.3.1 action of the seam end through the one of the double stroke. On opening starting the valve, the steam passes through the pump of the governor through the passage of the cylinder wall of the main valve of the chamber between the differential piston of the head of the main valve. It passes through the passage into the reversing valve chamber, giving equal pressure in both chambers. In the main valve chamber, the steam acting on the inside of the large head of the main valve overcomes the steam acting on the inside of the small head and moves the main valve in the direction of the large head. The main valve carries the slide valve in with it, and steam is emitted through the port of the bottom of the cylinder, thus forcing the piston up. With this piston near the end of the line or end of the stroke, the reversing part attached to the top of the piston strikes the shoulder of the reversing rod, lifting it lifts the rod, and as the rod is lifted with the reversing lever, it is carried up with it. At the end of the stroke, it is reached with the reversing valve closing the exhaust port, but it opens the emission port of the outside of the large head of the main valve. The steam on the outside of the large head of the main valve, the system with the steam acting on the inside of the small head overcomes the steam acting on the inside of the large head and consequently move down the main valve in the direction of the small head, carrying the slide valve with it. The exhaust cavity in the slide valve connects with the steam port of the cylinder, and the main exhaust passage allows the steam in the bottom of the cylinder to escape the atmosphere. At the same time, the steam is flowing with the main valve chamber through a port of the top of the cylinder, forcing the piston down where the near and the end of the downstroke, the reverse plate strikes the bottom of the end of the reversing rod, carries the rod, and reversing valve down. At the end of the stroke, the reversing valve at the close of the emission port of the opens exhaust port of the outside of the large head of the main valve. The steam on the outside of the large valve head escapes the atmosphere. The steam on the inside of the large head again overcomes the steam on the inside of the small head. The main valve again moves in the direction of the large head, carrying the slide over with the valve with it. The piston of the exhausting cavity on the slide valve connects with the top of the cylinder to the atmosphere. Steam flows through the admission port to the bottom of the cylinder and to again start the position on its upstroke. 12.3.2 actions on the air end of the one end of the double actions of the air end through one double stroke. When the piston is on its upstroke, the vacuum is forced with the lower end of the air cylinder. Atmosphere pressure is lifts to the bottom of the receiver of the valve. Air flows into the cylinder, flowing through the piston until it reaches the end of the stroke. At the same time, the air on the top of the piston compressed with the top of the receiving valve closed, with the air forced through the top of the discharge valve in the main reserve. On the downstroke, the vacuum is formed with the top of the cylinder. Atmospheric pressure lifts the top receiving valve, and the air flows into the top of the end of the cylinder, flowing the piston until the end of the stroke. At the same time, the air underneath the piston is compressed with the bottom of the receiving valve closed, and the air force went through the bottom of the discharge valve at the main reserve. The action continues whilst the pump is working. In Figure 14, Annex A. 12.4. Bulb triple valve. Description: the top of the valve body is situated with the triple position, a piston and ring sliding the valve with the spring and the gradually valve pin, and all working on the one stem. The slide valve bushing and the head necessary to support the passages to control the flow of the air through the train pipe with auxiliary reserve, from the air auxiliary reserve to the brake cylinder, from the pipe to the bulb, from the brake cylinder to the exhaust, from the bulb exhaust. There are feed grooves in the triple piston bushing. The valve faces the triple piston through which the flows with the triple in the release position are enclosed with the casing. Attached with the lower part of the body of the bulb is bottom in which the drain plug, inside with the bulb screwed with the siphon tube, and through which the air passes through the bulb when the application of the brake is made, through which the air is drained when it releases is made. A regulating plug in which, seated with the regulating valve spring is lifted. Spring is fitted to the body inside the bulb. The plug has three ports namely the valve port, equalizing port, and the control port, through which the air is passed to the brake cylinder. Figure 15, Annex A. Alright, 12.4.2, charging with auxiliary reserve. Air in the main reserve flows from the chamber in the top of the rotary from the driver's brake valve and the brake valve. The handle in the full release running position flows through the train of the pipe. If it passes along with the branch pipes, if the passes cover the triple valve of the body leading the train pipe at the side with the triple position, move the release the pump, release and charging piston. If the air flows through the feed groove, and the triple piston bushing past the piston ring and the auxiliary side of the triple piston. And if this then flows with the feed of the groove at the face of the piston, that's the slide valve of the auxiliary reserve that continues to flow until the pressure of the train pipe auxiliary equalizes. 12.4.3 Application of the brakes. Assuming the weight of the driver's brake with the reduction of pressure, say the left 7 pounds, has been made in the train pipe, the brake valve handle has been placed in the lap position, auxiliary pressure now being greater than that in the train pipe. The train triple position first closes the feed groove into the bushing and carrying the graduating valve with it, and opens the graduation port, allowing the air from the auxiliary reserve to flow into the graduate passage in the sliding valve. By the further movement, the triple piston moves the slide valve towards the application piston. The slide valve closes with the exhaust port with the brake cylinder, exhaust port with the bulb, and opens the communication with the train line and bulb. The air flows with the train pipe to the port connected with the narrow cavity in the slide valve with the port leading with the siphon pipe through the air flows through the bulb. The charging of the bulb causes the local reduction of the train pipe pressure and influences the movement of the succeeding triples along with the train, and thus tends to bring about a more simultaneously application of the brake throughout a train. The charging of the bulb speeds up the movement of the triple application position. The air of the auxiliary reserve there flows in the service port of the top regulating plug, compressing the regulating valve spring, thus unseating the regulating valve, opening the valve port through the air, which air flows to the plug. The air then flows through the control port with the brake cylinder, which exerts the force on the brake piston. The brake piston moves outward with the pressure of the release spring, and causes the brake blocks to contact the wheels at the pressure of the brake cylinder. Increases the conjunction with the regulating valve of the spring, which is a tension of 40 pounds per square inch. The auxiliary pressure on the top of the regulating valve is overcome, and the valve is reseated. Air from the auxiliary continues to flow with the brake cylinder through the equalizing control ports in the plug until its pressure is slightly less than the pressure of the train pipe. The triple piston will be moved toward the auxiliary carrying with the graduating valve. The only will close with the graduating port. The valve is known on the tap, will remain so until there is further reduction on the release has been made. After assuming the further reduction of 3 pounds per square inch has been made on the train pressure, the auxiliary pressure again becomes greater than the train pipe, acting on the triple piston, causing the latter movement towards the train pipe. The triple position carries the graduating valve, which opens the graduating port and allows the auxiliary reserve to pass the brake cylinder, and by the way, equalizing cylinder ports in the plug. But this applying with the brake cylinder is a little harder. The flowing of the air brake cylinder continues the auxiliary pressure against with the less of it, and that of the train pipe. When the triple piston of the graduating valve will again be moved to the lap position, successive reduction of the train pipe pressure can be made with the brake cylinder pressure consequently increased until the train line auxiliary reserve brake cylinder pressure are equalized. The brake will then have been applied with the maximum force. 12.4.4 Release of the brakes. By the means of the driver brake valve, the excess of the pressure of the main reserve is allowed to pass the train pipe, thus raising the pressure in the train pipe above and that in the auxiliary reservoir. Triple piston slide valves are then moved to the full release charging position. The auxiliary is charged with the previously explained in the fully released position. The triple valve closes with the communication between the auxiliary reserve and the brake cylinder, also between the train pipe and the bulb. It also communicates between the bulb and the atmosphere, between the brake flows with the siphon pipe, and through the port which is connected with the bulb exhaust means of the narrow cavity in the slide valve. The air in the brake cylinder flows along the passage of the triple body at the port of seat, which is connected with the main nipple exhaust means of the broad cavity in the slide valve. The brake is then being released to the bulb with the empty and auxiliary reserve recharged. 12.5 Numbers 4 Driver Brakes Valve. Note that if in tracing the flow of the air through the brake valve, the main reserve belt must be charged with the isolating cock open, allowing the air for the main reserve to flow with the passing the isolating cock up the pipe through the passage in the body of the top of the rotary valve. The main reserve air will then occupy the space above the valve, irrespectively of the position of the brake valve handle, which controls the flow of the air according to the position. 12.6 Operation of the numbered 4 driver brakes in the 5 position of the handle. Releasing and charging. When the brake valve is in the position main reserve, the air flows through the main supply of the port of the valve into the blind cavity in the body with the form of which it flows in the direction. In one direction, the air flows through the short cavity in the rotary equalizing charging port when connected with the passage across the body leading to the top of the equalizing piston of the small dry strum and to the black hand on the pressure gauge. In the other direction, the air flows under the bridge of the large cavity of the rotary valve, then down through the train pipe to the sudden supply port with the train port under the side of the equalizing piston through giving the equalizing pressure throughout the system. Air also flows through the top of the equalizing piston, the small drum to the black hand on the pressure gauge through the excess pressure on the port of the rotary valve of the preliminary exhaust port in the body. 2. Running position. The main reserve air on the top of the rotary valve flows with excessive pressure in the ports of the valve body and the feed valve. The governance of the flow of the air, thence to the passage into the body, leading to the train pipe under the side of the equalizing piston. From the flows of the top up to the train pipe supply of the port of the body of the large cavity of the rotary valve, with the conductor of the down in equalizing port to the top of the equalizing piston to the small drum to the black hand on the pressure gauge. When the train pipe with the pressure becomes equal to the setting of the feed valve, the later will be closing, cutting off the main reserve pressure to the train pipe. 3. Lap position. In the lap position, neutral position, all ports are closed with the communication between the main reserve of the train pipe with the cutoff of the main reserve being on the top of the rotary valve only with the train pressure below. 4. Service position. The rotary valve in the position along with the narrow gauge. The rotary valve in this position, the long narrow groove in the valve communicates with the narrow groove in the seat, which leads to the main exhaust. The connection permits air from the chamber above the equalizing piston from the small drum to the flow up the preliminary exhaust port into the body through the grooves into the seat of valve of the atmosphere. The reduction of the pressure above the equalizing piston causes the train pipe to under the pressure to become the greater, and the piston is forced up unseating the exhaust valve on this piston seat. The train line air then escapes the secondary exhaust, but the pressure below the piston is less than the top. When the piston is forced down, the closing of the secondary exhaust valve and cutting the escape of the air from the train pipe. Emergency portion. In this position, the large cavity of the rotary valve connects to the train pipe with the supply with the port of the main exhaust, causing the rapid reduction of the train pipe pressure in the brakes to be suddenly applied with the maximum power. The air on the top of the equalizing piston and the small drum escapes from the preliminary exhaust port via the narrow grooves in the rotary valve in its seat with the main exhaust. The reduction pressure is being registered in the gauge. Figure 16 shows the plan sectional view of the number 4 automatic brake. 12.7. The CM6 feed valve. The purpose of the CM6 feed valve. The purpose of the CM6 feed valve is to govern the pressure of the train pipe irrespectively of variation of the main reserve pressure, provided the main reserve pressure does not fall below the pressure of which the feed valve has been set. With the brake valve in the running position, the main reserve air flows through the excessive pressure ports within the rotary of the body of the driver's brake valve into a passage leading in the feed valve. If it enters, the feed valve flows down the passage past the back of the supply valve, which is connected closed with the normal position to the passage of the regulating valve, which opens in its normal position. The air passes the regulating valve, flows through the passage of the supply piston chamber that acts on the back of the supply piston and moves to its left. The piston engages the supply valve stem and unseats the supply valve, opening the communication between the main reserve and the train pipe. The train pipe air flows down to the passage into the body diaphragm chamber when the pressure in the diaphragm exceeds the setting of the adjusting spring, the spring is compressed with the diaphragm moved to the left, thus permitting the regulating valve to be closed by the action on the regulating valve spring. When using the closing of the regulating valve, communication is shut off between the main reserve and the supply piston chamber. The pressure on both sides of the supply piston equalizing the airflow between the spindle of the regulating valve and its guide. The supply valve is then reseating by the spring. Communication is closed between the main reserve and the train pipe. When the train pipe, the pressure is again reduced. The tension again adjusting spring overcomes the pressure against the diaphragm. The diaphragm is moved to the right, engaging the spindle of the regulating valve, then seating the valve. The main reserve air again flows to the supply with the piston chamber. The operation previously explained and is repeated. 12.7.2 Method of testing a CM feed valve. The rotary valve must not be blown through the automatic brake valve. The handle has been in the running position. Pump started. The black handle on the gauge should be advanced with the main reserve pressure in the stop at 70 pounds, thus indicating that feed valve is working freely and adjusting correctly. Alright, 12.7.3 Further test. The train pipe cock at the front of the engine is open slightly with great the leakage of the black hand on the gauge falls to 68 pounds, then returns to 70 pounds, continues to fluctuate between these points. This indicates that the feed valve is opening and closing correctly. The air escaping of the vent port with the adjusting spring chamber to indicate the cracked or defective diaphragm plate. If the rotary valve is not blowing through, the loss of excessive pressure may be caused by the leakage past the supply regulating valves, by a defective gasket between the body of the feed valve and the brake valve, by incorrecting the adjustment, overcharging the train pipe in case of much exhaust pressure obtained within lost the fault grid generally being traced to the directly supply and regulating valve. The trouble can generally overcome the adopting the following method. The isolating cock is closed at all train pipe with the exhaust with the opening of the cock at the back of the end of the cap. The supply with the regulating valve chambers are then removed. The supply valve and the spring, also regulating valve, the springs are withdrawn and cleaned throughout the with kerosene soaked cloth. The valve bushes are cleaned by the same method with the valves that are out in the tension of the spring to check with the brake valve with the handle with the place in the running position. The isolating cock open for a few seconds to remove any of the dirt passages. The valve springs are then replaced in the cock on the back of the tender closed and the isolating cock open and ready for service. Alright, 12.8 automatic slack adjuster. Purpose of the slack adjuster is to maintain a uniform piston travel with automatic taking up the slack caused by the wearing of the brake blocks. The inconsistent with a small air cylinder, the piston, the packing leather, which will help with the position with the expanding of the ring of the valve with the pawl spring and the piston spring cylinder head and casing of the ratcheting nut. The air cylinder connected with the pipe that leads with the predetermined port of the side of the brake cylinder. The ratcheting engine with the adjusting screw with the automatically take up the slack with the brake is released. 12.8.2 operation. Insufficient slack of the brake ring. The perimeter of the brake system is extended with the on the port of the side of the brake cylinder, and the brake is applied with the brake cylinder air with the pass through the port and the connection pipe. As they enter the slack adjuster, the slack adjuster will be forced out of the compressing the piston spring with the pawl spring will cause the ball to engage the teeth in the ratchet to the ratchet nut, which the brake is released, and the air pressure of the adjusting cylinder escapes the non-pressure side of the brake cylinder. This permits the adjuster piston spring to force the piston back, causing the ball to turn with the ratchet and nut consequently taking up the adjusting screw. The effect is that the draw towards the brake blocks near to the wheels. The arrangement is adjusted with the control of the brake. The cylinder piston travel to lay down for the purpose of renewing the brake blocks and setting the blocks correctly. The hand adjustments can be made turning the ratchet nut with a spanner. To slack the braking rigging with the adjuster crosshead of the brake, move the torque with the brake cylinder, tightening the rigging and shortening the piston of the travel to the crosshead and move in the opposite position. Alright, 12.9, passenger intercommunication gear on carriages. The arrangement is fitted with the carriages for the use of the passenger. In emergency, the brake pipe leads with the train pipe encased with the contains the spring-loaded valve, with the valve to be enclosed with the normal position operating rod with the cam that can be engaged with the valve stem and feeded with the bearings in the end of the carriage connected to this rod. The changing of the running of the tube, the opening the end of the carriage of the tube, having the opening end of each of the compartment that does attached to each of the end of the operating rod is a horizontal position and is when normal and vertical position. After use of the change is pulled with the compartment with the cam on the operating rod with engages the stem of the airflow with the opening of the valve release from the air from the train pipe, causing the brakes to be applied to close the valve. It is necessary to turn the disc on the operating rod so that it also releases the cam. The valve stem also allows the valve to be closed with a spring, thus preventing the further escape of the air to the train pipe. To engage the device and operate the successful drivers must also automatic brake valve handle the running of the position when not in use. Discretion must be used and is not to allow the train to stop the bridge when other passengers may allow, and also the case of interference with the gear must also be reported with the driver occurrence sheets. Chapter 13, General Westinghouse braking questions and answers.